Can you hear me?
Yes, sir, we can hear.
Okay. Does anybody have a question? No questions? Okay, then we'll continue from where we were discussing in the last class. I forgot to tell one thing. Define this particular quantity. So this is called as odds of something happening. Okay, so if you look at the formula here, it is probability of x divided by 1 minus probability of x. So what is it? So odds of something happening. Okay, you might have heard of this. The odds of this are so and so. Okay, or in boxing or other sports they have betting and all those things, so they define different odds. Okay, there is a possibility that this person might win. There are the odds of person A winning is so and so compared to the odds of person B winning. Okay, so what is odds? If you look at the formula, what does it tell you? So this is the probability of something happening divided by the probability of something. What? Bipul, what do you think? You there?
Yes, sir.
Can you repeat?
Yes, sir.
Yeah. So what is the denominator in this particular formula? The numerator is the probability of x happening. What is the denominator?
X1, X dash.
X dash. What does that mean? The probability of x not happening. Okay.
Yes. Yes, sir.
Okay, so odds is defined as the probability of something happening divided by the probability of something not happening. Okay, so what do you think? What ranges can odd take with this odds? What value, Bipul? You only have to answer. What is the possible ranges that this value can have? Odds can have. What is the possible values of px? What are the possible values of px?
0 to 1.
Huh?
0 to 1.
0 to 1. Okay, so what is the so if probability is close to 0, okay, so what will be this quantity odds? What will be the odds? What will be the odds?
0.
0. Okay, and if probability is 1, then
One.
what are the odds? If px is close to 1 or almost 1, what are the odds for that event happening?
Infinity.
Infinity. Okay, so the range of odds is between 0 to infinity. Okay, so it lies between 0 and infinity. So this quantity that we previously defined as log it, okay, it is also called as log odds. Log odds. Okay, we are taking the log of odds and also called as log it. Okay, anyway, this was just to cover so that other people could join in. Now I am guessing most of you are here, those who are planning to be here. So let us continue with what we were discussing in the previous class, which was how to find out the parameters beta 0 and beta 1 for a logistic regression for a one variable, one input, one output system. Okay. So we have, so this was what we usually have in linear regression. It is 1 over n. I is equal to 1 to n. we are using capital N. Okay. Now, actually, this does not happen in linear regression. In linear regression, something else happens. We use pxi, okay, whatever is your function, okay, minus yi, and then we do that. Okay, that is what happens in linear regression. If you look at what I mentioned in the previous class, which we did not have time for to discuss, what happens if I use fxi, which I have defined over here, instead of pxi. If I am defining my mean squared error, if instead of pxi, if I use fxi, what happens in that case? Is it better or worse? Do you think fxi is a better choice, or pxi is the better choice? What do you think? Vaishnavi, what? Jasvi? Yeah, Jasvi, go ahead.
So, so PXI, I think will be a better choice than FXI.
That's what I was thinking. Who is this Jasvi?
It's me, Medha. Actually, I have
No.
logged it from my home, and it is my niece's account.
Okay, that's fine. I uh, I was wondering who is this. Means I was surprised because I had never seen that name earlier. So what? Yeah, I was thinking about something else. So why don't you repeat your answer again, Medha?
So I think PXI would be a better choice
PXI would be a better choice. Why?
because it will give the MSC in. We can get a nearby value of MSC. In FXI case, we will either get 1 or 0.
Means you are right in one sense. Let me show you an example. Okay. So let us say, can anybody visualize what kind of function this is? What kind of function this is? Beta. Sorry. Let me draw something, and then it will become clear. So this is your x. Okay. This is your x, and we are. We have two kinds of values of x, okay, one which give output as 0 and one which give output as 1. So we are classifying. So let us look at something like this. Okay, so crosses correspond to ones, okay, crosses are ones and o's are zeros. Okay, so if x has these values, okay, if x takes these values, okay, my x and y look something like this. Okay, so please, are you able to understand what y is over here in this particular graph? What is y? Can you see y or no? Can you not see y? Can you see y here in the way I have drawn this graph? Can you see y or no? Vaishnavi? Yeah, crosses and zeros are denoting what y is corresponding to a given value of x. Okay, since we have only one dimension, since we have only one variable, one input x, so therefore a line is sufficient to denote the whole data. Okay, so each of these points is the play, so correspond to each of these inputs. Okay, so whatever, so this is your data set. From the data set, all the x's are plotted over here. Okay, that is how we have chosen these points. Okay, and so points are chosen in this manner. The symbol is chosen by whether the value of y is 0 or 1. If the value of y is 0, then I put an O over there, and if the value of y is 1, then I put a cross over there. Okay, so now if I were to ask you, what will be my decision boundary? Okay, so now let us say I get a new observation. Okay, I get a new observation. Let us say this. Okay, this pink dot is a new observation that you are seeing. Okay, and a previously unknown data. Okay, and your algorithm, your classification algorithm, has to assign an output to it. Okay, what do you think would be a reasonable output? What do you think? Based on what data you have seen till now, your algorithm has seen till now, what do you think the algorithm should do? What kind of value should the algorithm assign to this data point?
1. It should assign 1.
It should assign 1. Okay, so so that is primarily the basis. Okay, so we try to sort of we try to create a decision boundary. Okay, so based on this data we can create a decision boundary. In this case a decision boundary is going to be what? Your data is one dimensional, so what is your decision boundary going to look like? Your data is one dimensional. What? And we are using this kind of system. Okay, we are sort of using this beta 0 plus beta 1x. Okay, so what is your decision boundary going to look like?
A point.
A point. Okay, so let me use a different color. Let me use orange color. So this can be a decision boundary. Okay, that is a reasonable choice for the decision boundary. Now if I were to use this particular equation, let me use this. Okay, if I were to use this equation, fxi minus yi squared, okay, sigma whatever. Okay, if I were to use this equation, the equation that is written in orange, okay, what decision boundary will I get? Will I get a fixed decision boundary if I were to use this equation? Again, please remember, fxi is after the processing of probabilities has been done. Okay, I assign for a given probability, I assign value either 0 or 1. So fxi is that. Okay, fxi is no longer probabilities. Okay, so in this particular case, if I choose this decision boundary, what will be my error? If I choose this decision boundary, what will be my error? My mean squared error. Assuming that I have chosen this particular definition, if I choose this definition, what will be my mean squared error? Anybody? Dipanshu, what will be my mean squared error if I choose this as the decision boundary? Again, what I am talking about is
0.
decision boundary. Shivansh, what are you saying? Can you repeat?
I said that it will be 0.
Yeah, the error will be 0. Yeah, you are right. What about if my decision boundary was over here?
Till 0.
It will still be 0. What about my decision boundary being here?
Same.
It will still be 0. So if I choose this as my mean squared error, okay, this is my error function, then what happens in that case? What do I get?
Get same answer for many.
Yeah, so we will not get a unique answer. Most likely means we want most of our algorithms to give us a unique answer. Okay, because then there is a lot of arbitrariness built into this particular definition. So this is not a good definition. Okay, not a good definition. Definition for your error function. What about the top one, the traditional definition of mean squared error that we previously talked about? Do you think it is going to give me a unique answer or no, if I try to minimize this? Shivansh, what do you think?
Sir, this. But like, how does this doesn't depend on the decision boundary, right?
Can you repeat, Shivansh? I had a phone call.
Sir, how is the calculation of PXI related to the decision boundary?
How is the calculation of PXI? So, can you understand what this point is? What is this point? What is my decision boundary in this particular case?
So it means that before that.
So look at this equation. Okay, look at this. So where will my decision boundary lie? If I were to use this particular equation, where will my decision boundary lie? Can you tell me?
Px equal to 0.5.
Yeah, px is equal to 0.5. What happens at px is equal to 0.5? We drew a plot in the last class. The argument of this exponential becomes what?
Argument
Means exponential जो beta 0 to plus beta 1 x क्या हो जाता है उस समय पर when your this function is 0.5.
0 beta 0
Yes.
0.
So at decision boundary, so let me erase these things because we really do not need them anymore. So at decision boundary, let us say we have defined a decision boundary in this manner, okay, that 0.5 your probability of 0.5 is your decision boundary. At decision boundary your px is equal to 0.5. Is that correct? Okay, so what does that mean? What does that give you? That gives you that beta 0 plus beta 1 x is equal to 0. Is that all right or no? Do you get it or no?
Yes.
Shivansh?
Yes, sir.
So that is primarily the basis of finding out the values of beta 0 and beta 1. Okay, so if I were to use this particular equation, okay, if I were to use this particular equation to find out the point at which this becomes minimum, okay, I am trying to find the point at which the values of beta 0 and beta 1 for which this becomes minimum. How do I do that? What is going to happen? क्या होगा? So as I am moving, so let us assume, let us make our problem a little bit easier. Okay, let us say that we have 5 points on the left and 5 points on the right. Okay, if I have 5 points on the left and 5 points on the right, where assuming, let us say that I choose exactly middle point as my decision boundary. Okay, what is going to happen in this case? What will be my px size be? क्या होगा px size को? The pxi for this is going to be the same as pxi for this, isn't it? Or no? Not same, 1 minus same.
Yes, sir.
Like we have in semiconductors. Do you remember that it is 1 minus fx or fx ही होता है ना या for b function? Yeah. Do you remember that when we were talking about electrons and holes? शिवांश याद है?
Yes, sir. थोड़ा तो याद है.
चलो कोई बात नहीं, नहीं याद है तो भी कोई बात नहीं. So the probability of so let us look at that. Let us say that the distance of this is equal to the distance of this. Okay, if that is the case, what is going to happen? ये क्या होगा हमारा? Let us call this as point. This is point 1 and this is point 2. Okay, now p x1 minus y1 ये कितना होगा इस केस में? What will that be in this case? And let us call this as some
A.
this distance as, let us say, x dash. Okay, let us say it is x dash. Okay, px1 minus y1 ये कितना होगा? What will this be?
X dash.
It will be e to the power beta 0. Yeah, it will be x dash. Sorry, you're right. It will just be x dash. The distance between these two quantities is going to be x dash. Or am I wrong? No, it will not be. It will not be. It will be p. It will be p of x dash. Will it be p of x dash?
No, sir. Sir, वो e की power beta में.
Yeah, it will be. It will be p of x dash, isn't it? So it is going to be p of x1 minus your let's call this as x0. Is that correct or no? ये सही है या नहीं है?
अलग अलग से सब्ट्रैक्ट करना पड़ेगा सर.
No, no, no. Let me think about it. Uh, so this is your decision boundary. Okay. Here your probability is going to be 0. Yeah, you're right. We'll have to subtract them individually. So px1 minus y, px1 minus y, y1 is going to be what?
So that x dash
Yeah, yeah.
distance is on
Yeah?
the x-axis. The x dash distance,
Yeah,
is it on the x-axis?
yeah, it is on the x-axis.
Okay.
So that is the distance between the decision boundary and my point. Okay. So let us. Uh, so let me do something. Let me make this. Okay. So this is going to be p of my decision boundary. Okay. Let us call that as x0. Okay. My decision boundary. Let us call that as x0. Okay. It is going to be p x0 plus x dash. Is that all right? Can p x1 be written like that?
Yes, sir.
Yes,
Okay.
minus p of
Minus y1. Okay. So this is your first term. Okay. And what is y1 in this case? What is the value of y1? We know that. What is the value of that? It is क्या है वो? 1. ठीक है. Now similarly, let us look at p x2 minus y2. What is that going to be?
x0 minus x dash. P of x0 minus x dash.
P of x0 minus x dash. Okay. Minus. What is the value of y2?
0.
It is 0. ठीक है. So now let us look at this side. Let us look at this point. इसकी value क्या होगी? What is this function? This function is this sigmoid function that we previously drew. And what is the sigmoid function? It is symmetric around
x0.
around at a certain point. Okay. In this case, the certain point around which it is symmetric is what?
x0.
Is x0. Okay. So the value of p, it is not symmetric, but it is sorry. So let me write that. So p x0 plus x prime or p x0 minus x prime is going to be equal to what? इसको क्या लिख सकते हैं हम? 1 minus p of x0 plus x prime. Is that correct or no? Do you agree or not? So let me draw this again. So this is how your sigmoid function looks like, where this is your x0 and the value at x0 is 1 by 2. Okay. And it is symmetric around this point in the sense that the value here is equal to 1 minus the value over here. Do you all agree with that? Do you all agree or no? You can do that. You can do the calculation. Okay. If so do you all, is that okay or no? नहीं है? I don't think I'm getting across to you guys.
Sir, yes,
Okay.
sir. लग तो रहा है.
लग तो रहा है. Let us make it more concrete. लगना नहीं चाहिए. पूरा confidence होना चाहिए. So let us look at this. So let us look at this equation. So e to the power beta 0 plus beta 1 x0 plus beta 1 x prime over 1 plus e to the power beta 0 plus beta 1 x0 plus beta 1 x prime. ठीक है? So that is your this when we are using so let us look at, can we do something about this? Can we do something? Can we do something? Can we do something? Okay. So that is one part. Now let me do 1 minus this. Okay, 1 minus this quantity. Let me do that. 1 minus this quantity is going to be what? Let us look at that. So if I do this and I do 1 minus this, what do I get? मुझे क्या मिलेगा? क्या मिलेगा मुझे? 1 over 1 plus e to the power beta 0 plus beta 1 x 0 plus beta 1 x prime. Is that all right? ठीक है? And we know what? अब हम क्या कर सकते हैं इसमें? कुछ कर सकते हैं? We know something about this. What is e to the power beta 0 plus beta 1 x 0? उसकी वैल्यू क्या है? Can anybody tell me what the value of that is?
Yes.
What is the value of this quantity?
0 0.
Yeah, e to the power beta 0 plus beta 1 x 0 is how much? Beta 0 plus beta 1 x 0 is 0. So e to the power this is going to be what?
1.
1. Okay, तो और आसान हो गया यार ये तो मुझे सोच रहा था उससे भी. So e to the power beta 1 x prime. Okay, and so what do I have? I wanted to prove that this quantity was equal to, let me take let me divide the numerator and denominator by e to the power beta x. Okay, beta x prime, sorry. So if I do that,
सम दोनों क्वांटिटीज का 1 है तब भी काम होगा.
so if I do that, let me multiply both the numerator and denominator. Yeah, we can do that also. And that is also another possibility. We can do that. But since I have already flown on this path, let me continue. So e to the power minus beta x prime divided by 1 plus e to the power minus beta x prime. Here I have multiplied and divided the numerator and denominator, sorry, multiplied the numerator and denominator by e to the power minus beta x prime. Is that all right? Will it give me this or no?
Yes sir.
देगा या नहीं देगा?
देगा sir.
ठीक है ना? मैंने उल्टा लिख दिया है लेकिन but please understand that if I multiply by, I'll get a e to the power minus beta x prime over here. This will become 1 and this will be e to the power minus beta x prime. Okay, and I have rearranged these two terms and written them over here. Okay, now I also know what, that e to the power beta 0 plus beta 1 x 0 is how much?
1.
It is 1. So I can easily multiply that 1 over here. 1 के साथ multiply कर सकता हूँ यहाँ पर, कोई परेशानी है उसमें? I can multiply both these by 1. तो मुझे क्या मिलेगा उसके बाद? क्या मिलेगा? What do I get? 1 से मल्टीप्लाई किया and 1 is e to the power beta 0 plus beta 1 x 0 minus beta x prime divided by 1 plus e to the power beta 0 plus beta 1 x 0 minus beta x prime beta 1. This is beta 1. Is that okay? So what have we proven? We have proven that 1 minus p of x 0 plus x prime is equal to p of x 0 minus x prime. Is that okay or no? अब आ गया समझ में सबको या नहीं आया?
Yes sir.
दीपांशु कुछ आ रहा है समझ में? है?
हाँ सर आ रहा है थोड़ा.
ओके, थोड़ा बहुत नहीं, पूरा आना चाहिए. क्या नहीं आ रहा?
सर कर रहा हूँ मैं ट्राई सर, थोड़ा कैचअप करने में प्रॉब्लम हो रहा है.
Okay. Anyway, but it was much easier if you think about it through this graph. Okay, you don't have to worry about it too much. It is symmetric across the half point. Okay, wherever you have the value half, it is symmetric across that, in the sense that the value here is as far away from half as the value on the other side. Okay.
हाँ सर, ये इंट्यूशन तो क्लियर है कि ये थोड़ा
हाँ तो बस
सेम ही
यही बहुत है, अगर ये नहीं समझ में आ रहा कोई बात नहीं, ठीक है. आई ऑल्सो थिंक दैट दिस इज मच इजियर टू थिंक, okay, then to do this. Okay, but I have proven it mathematically or algebraically also. Okay, so where was I? मैं क्या प्रूव करना चाह रहा था? Yeah, so what is the value going to be in this case? इन दोनों की वैल्यू क्या आई? This is obviously we are going to take a square of these two quantities. स्क्वायर इसका भी लेंगे और इसका भी लेंगे, तो दोनों क्या होंगी? दोनों क्वांटिटीज क्या हो जाएंगी इन दोनों के स्क्वायर्स? नहीं केवल इतने में, बस अभी इतने में करो आज, ठीक है. सो हाँ, so what will the squares be? Anybody?
Equal.
They will be equal. Okay, so in one case we have 1 minus, sorry, p x0 plus x bar x prime minus 1. In the other case we have 1 minus opposite of that. So if we take squares of both those quantities, those both of them will be equal. Okay, and if you, what about if these two quantities were also the same, then they'll be equal, and so on and so forth. You might have studied this in when you're trying to prove that what is, so a lot. Logically speaking, this is the point where you will get what? यहाँ पर क्या होगा हमारा? इस पॉइंट पर हमारा क्या आएगा? Again, I am not getting a very concrete it is con है मिनिमम आएगा हमारे मीन स्क्वायर एरर फंक्शन का, ठीक है. एमएससी का हमारा मिनिमा आ जाएगा इस पॉइंट पर. ओके, सो वील गेट मिनिमा एट ओनली one single point, whereas if you are using this particular error function, what are we getting? We are getting minimas at infinite number of points between this the first 0 and the first 1. Okay, is that all right?
Yes sir.
ठीक है. Okay, so let us go back to which is better than either of these two. Okay, obviously this is not good. Now we have this mean square error function that we usually use, and the maximum likelihood function that we had talked about in the last class just at the end. Okay, so what are we doing here?
सर मेरे को एक डाउट है सर.
हाँ बताओ.
सर जैसे डिसीजन बाउंड्री से तो सिर्फ एक ही इक्वेशन मिलेगी ना, बीटा 0 या बीटा 1 की, मतलब बीटा 0 बीटा 1 कैसे निकलेंगे?
बीटा 0 बीटा 1 क्या
सर मतलब कि बीटा 0 बीटा 1 तो मतलब x0 तो सिर्फ एक पॉइंट है ना जिससे बीटा 0 प्लस बीटा 1 x पास करेगी, जहां पर वो 0 होगा.
हाँ
तो हमें स्लोप कैसे पता लगेगी, या मतलब एक और पैरामीटर कैसे पता लगेगा, तब ना हम पूरी लाइन बता पाएंगे.
हम लाइन बता ही नहीं रहे ना, हम तो पॉइंट बता रहे हैं खाली. द पॉइंट एट विच
फंक्शन उसमें तो यूज हो रहा है ना सर. वो
क्या यूज हो रहा है?
बीटा 0 प्लस बीटा 1 x.
So let us say that बीटा 0 की वैल्यू क्या आती है? बीटा 0 की वैल्यू आती है, let us say 4. Okay, बीटा 1 की वैल्यू आती है, let us say 2. Okay, can you tell me what my decision boundary is going to be? ये कैसे आया अभी भूल जाओ, ये दोनों कैसे आई ये भूल जाओ अभी, ठीक है. लेकिन अब मैं तुमसे पूछ रहा हूँ, तुम मेरे को डिसीजन बाउंड्री बता सकते हो?
-2.
हाँ,
-2.
so the point, the place where this beta 0 plus beta 1 x becomes 0, that is your decision boundary. ठीक है, तुम्हें बीटा 0 की वैल्यू पता है एंड बीटा 1 की वैल्यू पता है, so your decision boundary is going to be 2x0 plus 4 is equal to 0. Okay, so that will give you x0 is equal to -2. ठीक है,
तो मतलब बेसिकली मैं ये पूछ रहा था कि अगर हम इस अप्रोच से चले, इस वाले एरर से, मतलब तो हम क्या करेंगे कि लीनियर रिग्रेशन से पहले लाइन निकाल लेंगे और फिर जहां 0 हो रही है वो डिसीजन बाउंड्री हो गई.
means why will you apply linear regression? I don't understand what you mean. So please understand that here the decision boundary is not a line, it's just one point.
नहीं
Okay.
सर, बट हम बीटा 0 प्लस बीटा 1 x निकालेंगे कैसे? मतलब वो बीटा 0 बीटा 1 तो चाहिए ना हमें फिर देखने के लिए कि वो 0 कहाँ हो
तुम
रहा
बताओ कैसे निकालेंगे? इससे नहीं निकाल सकते?
है। तो इसको मिनिमाइज करना तो फिर वही हो गया ना लीनियर रिग्रेशन।
हाँ हाँ, वही तरीके से कर सकते हैं।
हाँ
या
वही
यू राइट।
वही कह रहा था सर कि
या
पहले वो करके फिर डिसीजन
पहले वो करोगे तो तुम्हें बीटा 0 और बीटा 1 की वैल्यू मिल जाएगी,
हाँ,
और
फिर
वहां से
उसको
तुम
zero-
वहां से तुम x0 निकाल सकते हो, द एग्जैक्ट पॉइंट।
यस सर वही
ओके,
क्लियर।
so let us yeah, we are talking about maximum likelihood. Yeah, so do you think that this is even better? So what are we doing here? We are multiplying all the probabilities for which the output is 1. Okay, we are multiplying all those probabilities for which the output is 1, and we are multiplying 1 minus the probabilities for which the output is 0. Okay, so if your classifier is good or your decision boundary is very straightforward, like for example in this particular case, what do you expect this to be? इन सारी quantities की value क्या क्या expect करते हो तुम? What do you think is going to happen to these quantities? If your classifier is good, what will these quantities be? Will these quantities be zero, close to 0 or close to 1? जो ये वाली quantity है. Did you say something, Shivansh? Can you repeat? Close to 1. Why? Because what is going to happen? So what are all the points I primes? I prime is such that yi prime is equal to 0. Okay, for all the, so I had previously said that this is the I prime. Okay, so these are the two I primes for which your y is equal to 0. Okay, so what do you expect your probability to be in this particular case? What do you expect your pxi prime to be? It is going to be close to, pxi prime is going to be close to what? 0.
0
ठीक है ना?
yes.
It is going to be close to 0. And what about if I were to talk about all the i's for which yi is equal to 1? That means all the observations for which my output is 1. Okay, I am multiplying those probabilities. Okay, so what do I want? I want when I'm getting 1, when my actual output is 1, what should my probability be? It should be, my decision boundary should be in such a manner that my probability should be close to what? 1. Yes, Jasvi. Can you repeat?
I said 1, sir.
Huh?
1.
Yeah, it will be close to 1. And if my decision boundary is good, then what should my probability of finding a 0 should mean? What should the probability corresponding to a point where I'm getting an actual 0? What should the probability corresponding to that be?
1.
It should be 0. ठीक है ना? So that is what we are doing here. We are trying to maximize for all possible cases that the probability of each individual point where my output was 1 should be close to 1, as close as to 1 as possible. Similarly, the place where my actual output was 0, those probabilities should become as close to 0 as possible. Okay, and when I'm doing 1 minus this, I'm trying to, so if the probability is as close to 0 as possible, then the probability 1 minus that probability is going to be as close to 1 as possible. Okay, so this is this quantity in an ideal scenario. In an ideal scenario, this quantity will be as close to 1 as, means almost close to 0 for all values of I prime, and this value will also be close to 0, 1 for all values of I. Okay, so in both these cases, we want so that our decision boundary to be such that these values become 1 and these values become 1, both of them become 1. Okay, and I'm saying that this is better than this. Okay, why do I say that? Again, this is almost exactly the same as this. Okay, except that in this case you are minimizing something, and in this case you are maximizing something. That is all. Okay, so this is almost the same as that. Other than but please try to see if one observation here is going to make a big difference or not. इस केस में क्या होगा अगर तुम्हारी एक ऑब्जर्वेशन गलत हो जाए? Okay, let us say one observation becomes wrong in this particular case, then what is going to happen in that case? उस केस में क्या होगा?
स्क्वायर का सम होगा तो it will affect
स्क्वायर का सम होगा, लेकिन इफेक्ट इतना नहीं आएगा. लेकिन इसमें एक भी गलत हो जाए तो क्या होगा?
काफी इफेक्ट आएगा.
काफी इफेक्ट आएगा. Let us say if my actual value was 1, okay, if my actual value was 1, okay, and my pxi comes close to, let us say, 0.1, then what is going to happen? Even if everything else was 1, even one observation is going to do what? Please, you can keep multiplying ones as many times as you want. What is the output? It's always 1. Okay, so even if one value becomes 0.1, okay, if the actual output was 1, okay, and the pxi calculated here comes out to be 0.1, then my likelihood becomes what? This likelihood function becomes 0.1. Okay, it affects a lot, and that is what we want in classification. We want to, so it's not like regression. Okay, regression, if your output is different by 0.1, it does not make a difference. Okay, but in classification you have only two choices. Okay, so you want to make the penalty for getting something wrong to be really strong. Okay, because you have only two choices, you either 0 or 1. Okay, you do not, so in linear regression you assign penalties using this, okay, where a small mistake does not make a big difference. Okay, but here you do not have much choice. Okay, your mistake is going to be either 0 or it's going to be huge. Okay, so you do not want any mistakes at all. Okay, you want to try to make your classifier such that you get no mistakes at all, and even if you get mistakes, each mistake is penalized very severely. Okay, so that you try to come close to a situation where you get no mistakes at all. Okay, so in this case, if you choose a decision boundary, there's a possibility that your your decision boundary may cause mistakes. Okay, but in this case the possibility is reduced quite significantly because the error associated with a mistake is very large. Okay, any questions anybody has? Can you see the intuition behind this maximum likelihood function being better than this for classification? Can you see that? Rohit, what do you think? You there? Don't want to answer. Vishesh?
Yes, sir. Yes, sir.
Are you understanding what is going on?
Yes, sir.
Sure?
Sure, sir.
Okay. Asha, do you have anything to add?
No, sir. It's perfect.
Okay, thank you. Okay, so let us continue. So again, we are not going to go into the mathematics behind how to solve this maximum likelihood function. Okay, we'll be using libraries to do this, and that is how we are going to proceed further as far as maximizing this maximum likelihood function is concerned. Okay, you can just use those libraries and maximize your function. We'll not go into mathematics of how to solve these.
सर सर
Yeah.
सर तो ये मैक्सिमम लाइक्लीहुड फंक्शन में भी एक डिसीजन बाउंड्री तो होगा.
हाँ, वो डिसीजन बाउंड्री ही तो कैलकुलेट कर रहा है मैक्सिमम लाइक्लीहुड फंक्शन. इसको हम मैक्सिमाइज करेंगे. इस फंक्शन वील ट्राई टू मैक्सिमाइज दिस. हाउ विल वी मैक्सिमाइज दिस? बाय चेंजिंग द वैल्यूज ऑफ बीटा 0 and beta 1. We'll try to find the values of beta 0 and beta 1 that maximize this particular maximum likelihood. Yeah. So
अच्छा, so that we will find using libraries.
yeah,
Oh, okay, sir.
I'm not telling you how, means I also don't know. I did not study that, but how to maximize this, that is what I'm not telling you. Okay, but we'll use libraries to do that. Okay, we'll use a black box which will give this as the input, and we'll get out beta 0 and beta 1. Okay,
Okay, sir.
so now let us move dimensions a little bit. Okay, so if we have multiple predictors, okay, so predictors is usually denoted by the term p. Okay, p is number of features. Okay, number of features or number of predictors. Okay, so if p is greater than 1, Okay, let us take an example of p is equal to 2. Okay, number of predictors is 2. So in that case, what will your so mm, let us take an example of metal length. Okay, and you have oxide length. Okay, so let us do a first introduction of semiconductors into this particular course, and let us look at an example. So this is the length, or instead of oxide length, let us make it channel length. So this is your channel length. This is the cross section of a MOSFET, if you don't remember. Okay, this is the cross section of MOSFET. This is your source, drain. This is your gate. Okay. Okay. And this is what? What will this be? This is the channel length. This will be the length of your metal. Is that all right? Let me call this as length of metal. Okay, this is metal oxide semiconductor. Okay. Now let me ask you, if the length of the metal is going to be smaller than the length of the channel, will it work well as a MOSFET? Shivansh, Dipanshu, go ahead.
No, sir, I guess it won't work.
Huh?
Sir, it won't work.
It won't work because it will not create a channel throughout your this channel region. Okay, if the metal was smaller than the length of the channel, then you will not get your transistor is not going to work. Okay, so let us say that this is my 45-degree line. Okay, for any device where your metal length is smaller than your channel length, then what do you get? So these are this is the 45 slope equal to 1 line. Okay, so in all these cases, what do you have? So X corresponds to MOSFET not working. Okay, and O corresponds to MOSFET working. Okay. So let us say we had no idea that this was true. Okay, that this 45 degree that this should have happened. Okay, let us say we had no idea. We are really dumb. We do not know that, but we do some experiments and we come up with this particular plot. Okay, showing the places where my MOSFETs do not work. Okay, and the places where my MOSFETs work fine. Okay, is that all right? Does everybody understand the example or no? So this is the length of the metal on the y-axis. Okay, and we have drawn the length of the channel on the x-axis, and we have drawn each point as either a 0 or a cross. 0 means that the MOSFET works fine, and cross means the MOSFET doesn't work. Okay. So now, if I wanted to do what will my decision boundary look like in this particular case?
A line.
Previously, it was a one-dimensional data, so my decision boundary was a point. Okay. Now we have two-dimensional data, So my decision boundary becomes a
line.
one dimension smaller than your data set. Okay, so your data set has 2 dimensions here, so you have 1 dimension smaller than that. A plane smaller dimension is a line. Okay, so your decision boundary will look something like this. Okay, ideally what should happen? It should be a close to a slope equal to 1. Okay, now how would you solve for this in this particular case? So now your logistic function will look something a little bit different. Okay, let us call this as, this is x1 and this is x2. Okay, so here x is now a vector, okay, containing x1 and x2. So x is now a vector which contains x1 and x2. Okay, so beta 1 x1 plus beta 2 x2. Okay, similarly in the denominator we have beta 0 plus beta 1 x1 plus beta 2 x2. Okay, we'll again use a similar what methodology for decision boundary. What is the decision boundary here? So decision boundary is going to be beta 0 plus beta 1 x1 plus beta 2 x2 is equal to what? हमने डिसीजन कैसे, हम हाउ आर वी डिसाइडिंग? वी आर डिसाइडिंग इफ बेस्ड ऑन px. ठीक है ना? So our final decision, okay, final decision happens in such a manner that if px is greater than or equal to 0.5, then I assign a 1. Okay, if px is less than 0.5, then I assign a 0. Is that all right? ठीक है ना? So my decision, what is my decision point? The decision point is where my px is equal to 0.5. And where is my px is equal to 0.5? The place where the argument of this exponent is
0.
what?
0.
0. Okay. So ये क्या देगा हमें? What does this give me? This give me a straight line in x1 and x2, isn't it? ठीक है शिवांश, अब आ रहा है समझ में? थोड़ा थोड़ा और क्लियर हो रहा है पहले से?
Yes sir.
ठीक है, हमें यहाँ से एक स्ट्रेट लाइन मिल जाएगी. एंड फॉर ऑल वैल्यूज वी ऑलरेडी नो दैट, बट वी कैन ऑल्सो do an analysis. So this will give you this straight line corresponds to this pink line over here. Okay, and anything above this line is going to be what? Greater than
0.5, so it will be
greater than 0 means we are talking about line px is obviously going to be greater than 0.5. Yeah, you're right. Okay, but this value beta 0 plus beta 1 x1 plus beta 2 x2 is going to be greater than 0 over here and less than 0 over here. So this region will correspond to, sorry, I made a mistake. On this side it will be less than 0. On the left hand side it will be less than 0. On this side it will be greater than 0. ठीक है ना? गलत बोल रहा हूँ, सही बोल रहा हूँ? क्या होता है?
सर लेफ्ट साइड ही होगा ग्रेटर देन 0.
ऊपर ही होगा.
ऊपर ही होगा.
ट्रू वैल्यूज होंगी ना बाउंड्री के ऊपर. ट्रू
सर मतलब कि हम सेम x पे ज्यादा y ऊपर मिलेगा ना.
एक सेकंड सोचने दो.
मतलब किसी भी पॉइंट है कोई x का, उसको हम ऊपर एक एक्सटेंड करेंगे तो सेम x पे ज्यादा y मिल सकता है. नहीं कंफ्यूजन हो रहा है x का.
कुछ तो गड़बड़ सोच रहे हैं हम. Let me think about it.
तो जैसे बीटा 0 प्लस बीटा 1 x1 प्लस बीटा 2 x2 तो प्लेन की इक्वेशन है, लाइन की नहीं है.
Yeah, you are right.
So
I
वो
made a mistake. So this will give me a line.
मतलब प्लेन होगा शायद से ऐसा कुछ. डिसीजन बाउंड्री एक लाइन है बट जो इक्वेशन है वो एक प्लेन है, वैसा कुछ ऐसा शायद से. जैसे उधर डिसीजन बाउंड्री पॉइंट था लेकिन इक्वेशन तो लाइन की आ रही थी.
No, this will be no. This is the equation of a line, no, between x1 and x2.
सर बट
x1 और x2 के बीच में लाइन है ना ये. भाई तुम एक चीज को कंफ्यूज कर रहे हो. वी डिड नॉट राइट इन द प्रीवियस केस ऑल्सो, वी डिड नॉट राइट दैट y इज इक्वल टू बीटा 0 प्लस बीटा 1 x. Okay, we wrote this as equal to 0. So what is this going to give me? This is going to give me 1 point. That is not an equation of a line. This is not an equation of a line. Similarly, this is not an equation of a plane. This is an equation of a line between x1 and x2.
यस सर ये तो सही है.
अब इससे आगे सोचने दो जरा. So if this is equal to 0 and I increase my x2, इन दोनों में से एक चीज वो होगी, क्या होगी? In one of these two quantities is going to be a negative quantity. Is that correct for this particular case?
Yes, sir.
हाँ या ना?
Yeah, yes, sir.
सर
So yeah, we can decide. Actually we can choose. इन दोनों में से दोनों opposite signs के होंगे. Please understand that. Okay, so anything beyond this is going to be of a sign which is either negative or positive, and this is going to be opposite of that. Okay, so let me show you one thing. Okay, what is that thing? Is that this line is exactly the same as beta 1 x1 minus beta 2 x2. Do you think these two lines are the same? Do you agree or no?
यस सर.
Do you all agree or no?
यस सर.
These two lines are the same. ठीक है ना? But if I were to choose only this part, अगर मैं केवल इस पार्ट को देखूं तो क्या होगा? इस पार्ट को देखूं तो क्या होगा? If you look at only this part, don't look at this. If I were to calculate this value, okay, this is going to give me positive for anything that is on one side, and it is going to give me negative on the other side of the line. Is that correct or no? ठीक है ना? आ रहा है समझ में सबको या नहीं? लाइन के एक साइड में ये पॉजिटिव वैल्यूज देगा और दूसरी साइड में नेगेटिव वैल्यूज देगा. Do you all agree or no? बोलो भाई.
यस सर.
ठीक है ना? एक साइड में, क्योंकि एक जगह पे जीरो है तो एक साइड में पॉजिटिव आएंगी, एक साइड में नेगेटिव आएंगी. ओके, नाउ यू हैव टू डिसाइड which of these two lines you want to choose. Okay, which of these two lines you want to choose based on what your values of 1 and 0 are. ठीक है, इस साइड में हमने 0 ले रखे हैं, so we have to decide, we have to make these quantities negative and these quantities as positive by deciding on which of these two lines is preferable to me. ठीक है, is that all right? Means both of them are same line. Okay, please understand that both of them are same line, only the signs of the coefficients are different, which do not really matter as far as this particular decision boundary is concerned. Okay, so you have to decide based on so let us do something.
सर तो मतलब जैसे इस केस में बीटा 2 पॉजिटिव लेंगे हम. नहीं.
इतना स्ट्रेट फॉरवर्ड नहीं है. Let us look at this. Let us say we make a line like this. Okay, y is equal to mx. Okay, both of them are 1. Okay, and it is passing through 0. Okay, 0 से पास कर रहा है तो हमारा बीटा 0 भी चला गया. So we get beta 1 which is 1 और x1 minus x2 is equal to 0. ये लाइन आई ना हमारी? आई या नहीं आई? ठीक है, assuming that this is passing through 0 and the slope is 1. Will this line correspond to this or no? Do you agree? Anybody? Come on.
Yes, sir. Yes, sir.
Agree?
Yes, sir.
Okay. So if I choose this as my, this is x1 and this is x2, so what are these values going to be if I choose this as my line? अगर मैं ये वाली लाइन चूज करूँ, x1 minus x2 चूज करूँ, then what are my these values going to be? क्या होगा उन वैल्यूज को?
पॉजिटिव।
Positive. Okay, these will be positive. Okay, and what are these values going to be on this side? इस साइड में हमारा पॉजिटिव आएंगी और इस साइड में हमारी क्या आएंगी? नेगेटिव. ठीक है ना? बट इफ आई वर टू चूज x2 माइनस x1 इज इक्वल टू 0, अगर मैं इसको चूज करूंगा तो
उल्टी आएगी।
ऑपोजिट आ जाएंगे. ठीक है. So we have to decide based on what my initial data is, which of these two am I going to choose. Okay.
जैसे मैं एक तरीका सोच रहा था सर कि अगर हम कोई भी पॉइंट 0 वाली साइड पे लें, मतलब जहां पर मॉसफेट वर्क है, और
हाँ.
उससे हम पॉइंट नीचे ड्रॉ करें उस लाइन पे,
हाँ.
तो सर उस पॉइंट को हम x, मतलब चैनल लेंथ x1 को तो x1 ही लिख सकते हैं हम, और x2 को लिख सकते हैं उस पॉइंट पे जो लाइन का y होगा प्लस समथिंग.
Okay.
तो सर वो वाला पोर्शन तो 0 हो गया, बस बचा β2 इंटू समथिंग, वो पॉजिटिव होना चाहिए. तो उससे हमें पता लग गया कि β2 पॉजिटिव होना चाहिए.
β2 पॉजिटिव होना चाहिए.
मतलब इस केस में
नहीं, इस केस में तो β2 नेगेटिव है ना.
नहीं सर, मॉसफेट तो उधर वर्किंग है ना, तो
हाँ, तो वर्किंग का मतलब 0 है.
वर्किंग का मतलब 0 से बड़ा है.
नहीं, 0 है.
जीरो.
मतलब
zero
वो
का
0 1 वाला 0 1 वाला 0 है. दिस x corresponds to 1. Okay, and this corresponds to a 0.
अच्छा अच्छा, उल्टा है. ठीक है.
उल्टा है. तो इसलिए हमारा बीटा जो है वो हो गया, क्या कहते हैं, नेगेटिव हो गया.
Yes.
β2. ठीक है. चलो, एनी अदर क्वेश्चंस? अदरवाइज वील स्टॉप. Has your class already started? Next class? Or you don't have a class? Anyway, I'm not going to continue.
सही
Okay
बात
then. Which class do you have?
सर, कम्युनिकेशन सर.
Okay, bye bye.